For section 5.3 in our study of probability, I am going to warn you guys, it's going to start off really easy and you'll be like, oh, I love probability. But probability does have a little bit of a dark side. From an old movie, I often say probability is the best of times and it's the worst of times. Sometimes it's so easy, it's so fun, but you can actually get some incredibly difficult questions in probability where you wonder if you could have figured that out on your own. But I'll do my best to explain it, and then practice will help us out. So let's start with the really nice. Probability is something that most people understand far before they get to a high school stats course in grade 12 or even a university one. Symbols are not hard. The P just stands for probability. The E is just saying it's an event. And probability is always favorable outcomes over the total. Okay? And whether it be a coin, a dice, a deck of cards, like whatever it is. So to introduce the idea, it really isn't bad. What we're going to do is we're going to talk about a deck of cards. It's one of the most common ways to give probability questions because it's really easy to understand and there's a great visual. So what we'll do is we'll take a look at a standard deck of cards. You might be wondering, why do we keep saying standard again? Well, there are certain card games where you'd be using jokers. So instead of 52 cards, there could be more. We will never do that. Okay? We will only use just the 52 cards, the 13 of each of the suits. So it starts off again really nice. The very first question says, what is the probability of being dealt an ace? So that probability is one where somebody far younger than you could figure it out. We're going to do it in a very formal way and not just to look fancy. What you would do at a senior level is you would write down the probability of this event. You could even code it. You could write the word ace down there. Most university profs will probably just write down an E. And then, how many aces are in the deck? Well, there are 4 aces of each suit in the deck. How many total cards are there? 52. So you'd have a 4 in 52 chance of drawing a random card and getting an ace. In probability, you will often reduce a game. Anything you hand in to me, I'll accept it there. The reducing, it's right, you can do it, but that's not really my concern. That's not something that I think is what we need to really focus hard on. So then, just to kind of get used to it again, what would be the probability of drawing a face card? So a face card, well, it's the ones that have faces on it. That's for all the people who haven't grown up playing cards. Our probability. The probability of this event, well, there are actually 12 face cards. There's the Jack, King, and Queen of each of the 4 suits out of a total of 52. And we would then be able to reduce. Again, that's not my concern, so I will leave it. The next example, where things don't get too crazy hard yet, okay, would be, what is the probability that you draw an 8 or a 10? Now, this isn't crazy hard, and this is where we start to realize, oh yeah, there's more on the go. How many 8s are in the deck? Well, there's 4 out of 52. How many 10s are in the deck? There's 4 out of 52. Now, here is where this was introduced just once at the end of chapter 4. There's going to be 2 very important words in probability. One is or, the other is and. And you have to know which is which. What does it mean? And I'm just going to come straight out and tell you what this one is, and then I'll give you a little way to say it. The or always is going to mean addition. The and is going to mean multiply, and we'll do examples of that. So when we add this up, 4 plus 4, we get 8, and we have a built-in common denominator of 52. That is going to be what our probability is. And here's an easy way to justify it. Let's say I said to you, I will give you bonus marks on your next assignment if you can randomly draw a 4 or an 8, or in this case an 8 or a 10. Let's go with the 8 or the 10. Well, here's the thing. If I said just an 8, no 10, you'd have a 4 out of 52 chance of this card being an 8. But now we have more chances because the random card can be either an 8 or a 10, okay, and let's just see how we did. Nope, didn't get it. We have more chances. So the word or means addition. It's not too hard to do. Now, for our next example, what we're going to do is bulk it up. And this one, it would have been said out loud if we were face to face, and so I better kind of highlight that right now. Let's say I gave you one card and then gave you a second card. What is the probability they are both spades? So the probability of this event starts off very, very simple. The probability of this event, What is the probability this first card is a spade? Well, there's 13 spades out of a total of 52. Now, this card is here. When I bring my next card in, here's what we're doing. We are assuming theoretically that's a spade. We don't worry about if it's not. That's not our problem. What happens is, this is a spade. There's only 12 more spades left. So the probability of the second card being a spade is just 12. How many total cards were left in the deck? Only 51. Now I'm going to hand this card out and I'm going to hand this card out. That means we multiply. That means we multiply to get our correct solution. Now, we move to our final example, and again, the PDF notes don't have it written down very clearly, so I'll say it out loud. Let's say I was going to do you guys a 5-card hand. This is kind of like an old school classic poker hand. I always think from the Old West. So you got 5 cards here. And what if I asked you guys, what is the probability of all of these guys being hearts? Okay, and so in this question, we have to do something very, very different. And you're going to realize, okay, probability, yeah, it is really, really fun. It's really cool. It can be really easy. But then you can bring in some very, very high-end problems. So for this one, here's what I'm going to get you guys to do. I want you to remember that probability is favorable over total. I had a university prof who always wrote a J over N. It took me a while to figure that out. The J was just the favorable, the N was the total. Don't worry about that if you don't like it. I can take that away. Now, for this guy, we have to do something that we have not done yet in this chapter. And then again, you see why chapter 4 was the lead-in. When we try to say how many different 5-card hands are there, that would be the total. Well, how many different 5-card hands are there? Don't worry that these are not all hearts. Well, this would be one 5-card hand. If I bring in this, that's another one. How many would there be? We have to use a combination. 52C5 would be the total number of 5-card combos that we could have. Now, how many different ways could we be dealt 5 hearts? Well, that is a whole nother ballgame. If we take a look, and just give me a moment to set myself up. Here is one way that there could be hearts dealt to you. This is one of the options. This is one of the 5-card hand hearts. But if I took the 5 away, well, now there's another one. How many different 5-card hands are there that are all hearts? It is 13C5 because there's 13 total hearts. And we want to say how many groupings, how many combos of 5 can we take? What you see is probability takes a giant step up. And these guys, you put them straight into your calculator. And then when you see the final answer of 1,287 divided by 2598960, you start to realize I don't really care about reducing. If you can understand why you had to use a combination, the reducing is the least of our concerns. Now, that is the end of using cards. The end of the day, number 3 in the PDF notes, then throws another curveball. Probability is not just coins, dice, and cards. You can use probability in many, many different ways. And we've done this before. We've talked about Olympic sprinters, the Olympic finals, the 100-meter. There's 8 racers, and then you have first, second, and third, gold, silver, and bronze. So what if we said, what is the probability of 3 good friends? I called them Joe, John, and Frank in the PDF notes. What is the probability of those guys being the top 3? And we don't care about who is who. We don't care that Joe was first and John was second and Frank was in last place. We just want those 3 to be there in any particular order. So we want to figure out what is the probability of this event. Now, this is where there's 3 out of the 8 that we're looking to finish. What would be the total number of ways gold, silver, and bronze would be awarded? In this guy, it would be actually a permutation. 8P3 is the total number of ways that the gold, silver, and bronze could be awarded. Now you got to be careful. A permutation is always when order matters, and then you see in the PDF notes it says in any order. What we're saying is for Joe, John, and Frank, it can be Joe first, John second, Frank third, or it could be Frank first. What happens up here is we go 3P3. And how many different ways can Joe, John, and Frank be awarded first, second, and third? If we type this in, this is our probability. There's 6 different ways for Joe, John, and Frank to be first, second, and third in order. And there's 336 ways for this race to unfold with all of the racers. There would be a secondary way to do this top guy. Okay, you could actually just do a straight factorial. 3 factorial is 6. There's 3 people, and how many different ways can you organize those 3 people?